All right, so this next section, we're talking about simplifying and writing algebraic expressions. Before we do that, we need to know some vocabulary or some concepts in order to do these next set of problems. So the first one is a term. What is a term? So a term is a number, variable, or a product of numbers and variables raised to a natural number powers. So here are some examples that they give us here. So all of these are different examples of a term. Okay. The next one is a coefficient of a term. So the coefficient of a term is a number that appears in the term. If no number appears, then the coefficient is either 1 or -1. So let's go do these ones in the bottom here first. So the coefficient of this xy is -1. The coefficient of -4x is -4. The coefficient of x is 1, right? Because that's what it's saying. If there's no number that appears, then it's 1. Now this one over here is strange because there's no like variable, but technically this is x to the 0 power. Okay. So 12, say 12x, it doesn't matter, it doesn't have to be x, it can be any letter, but 12x to the 0 power. So that's the same thing as saying 12. Okay? Because x to the 0 power is 1, right? So anyway, so the coefficient of this is going to be 12. All right, and then like terms, we've mentioned several, talked about combining like terms, things like that. So, um, so 5m and -6m, they have like terms, which is the m part. You have the x square here, those are the like terms, x, y, so on and so forth. Okay. Combining like terms, so like terms can be combined by using a distributive property. Okay, so just different ways of showing you how to combine like terms. Okay, in this case, it's by the distributive property. So okay, all right. So let's do um, some examples here. So pause here for a second. Okay, so the key part here is combining like terms, and if we can simplify them, great. Okay. Okay, so for this one, what we want to do is we want to combine like terms. So we have 4/3. Okay, so we're going to combine these guys together, 4/3, and then -1/3. All right, so 4/3 -1/3, that's going to give us 3/3, right? Because 4 minus 1 is 3, and then we have, the 3 stays the same. So we get 3/3z. Okay, and then we're going to combine these guys together. -100 plus 200 is going to give us 100, right? So that's plus 100. So if we simplify that, 3/3 is just 1. So 1 times z is just z. So z plus 100 will be our answer for the first one. All right, second one. We want to, again, remember PEMDAS is a way of attacking these problems. So we want to do, well, we can do both ways here. We can attack and go inside the parentheses first, or we can distribute the 6. Okay. So, well, we can't do anything inside, correct? Because we have an A and then there's a B here. We can try to combine, we can find an LCD and combine it that way, but it's going to make our life more complicated. So I suggest, uh, since we can't combine it naturally because this is an A and that's a B, what I can do is I can just distribute that 6. Okay. So when I distribute that 6 to each term, let me rewrite that. So we get what? 6 times 1/2 A minus Okay. 6 times 1 6b. Okay. And I still got the minus 3b out in the front. Okay. So I just distribute that. And I like this better because I know 6 times a half or half of a 6 is just 3, isn't it? So that would give me 3a. And this one, same thing here. 6 can go into 6 one time, or 6 times 1/6 is just going to give me 6 over 6, which is equal to 1. All right. So I like that better. So we get negative b here. Okay. And of course, we still got the minus 3b here. All right. And then we combine like terms. So that gives us, let's see here, 3a minus 4b. All right. Because this is a minus 1b. Okay. For the next one, same thing, right? We do inside the parentheses first, but again, we can't simplify that any further. So we take that negative 1 here and then we distribute it. Okay. So negative 1, distribute that to each term. So we get negative 5 minus 5x plus 6. Okay. Then I combine my like terms. I don't have any other x's, but I have the ones with no x's. So I'm going to put those together. So I have what? Negative 5x, and then negative 5 plus 6 will give me a positive 1. All right, so let me pause there for a second. All right, so same thing here, right? We got to do distributive property. So I distribute the negative 5 to each term, and then I have a negative 1, distribute that to each term. So we get negative 5a minus 5b minus a minus b. Okay. Then I combine like terms. So I combine these guys together and then I combine those guys together. So that gives me a negative 6a and then minus 6b. And there is our answer there. Okay. And then for the last one, again, we're going to combine like terms. So, um, so we're going to combine these guys together and then combine these guys together. Notice that we have 6 in the denominator and 12 here. So what I can do is I can multiply this to have the same common denominator. I can multiply this by 2 over 2. Okay, so that will give me 10/12 y squared plus 1/12 y squared. So now I can add them because they have the same common denominator. So 10 plus 1 will give me 11. Okay, so that gives me 11 over 12 y squared plus I have these guys, right? So negative 4 plus 3 is going to give a negative 1. And there's our answer. All right, so I want to divide this, right? Oops. So we know a negative divided by a negative, right? A negative divided by a negative is going to give us a positive. A negative divided by a positive is a negative. Positive divided by a negative is still going to give me a negative, and a positive divided by a positive is going to give me a positive. Okay, so again, negative divided by a negative, that's going to give us a positive. And then notice that we have 0.1 divided by 0.1. They're the same thing. So that's just going to give me 1, right? This goes into 0.1 one time. So we have a positive 1, and then we have the y left over. So that first one is just going to be 1y, or just y. Okay. For number 2 here, 2 over 7, I cannot simplify that any further, but I can cancel out the x's, right? Because x can go into x one time. Okay, so that's 2 times 1 is 2. 7 times 1 is 7. So the answer there is 2/7. Okay. All right, so I did the first two for you, so but that's very similar thinking process for the other ones. Now, four and five is a little bit more challenging, but you can do it. All right, so for number three here, right, we have y's in the top and y in the bottom, so I can cancel that out. And I also have x on top and x on the bottom, so I can cancel those out, right? So that just becomes 1. And then 3 over 6, well, 3 can go into 6 two times, and three can go into 1. Sorry, 3 can go into 3 one time. So this is going to give us a negative 1/2 as our answer. Okay. Now for this one, let me rewrite this, okay? Because these types of problems a lot of students miss, okay? And remember, just remember this. What does this mean? If I were to rewrite this, right? This means I would have 18y over 9 plus 9 over 9. Isn't that what that means, right? Okay. Um, so in order to rewrite it as one term, I can combine the top by writing as 18y plus 9, and I have the denominator 9. But in reality, this here is broken up into this, right? This is what it was before it was written as 18y plus 9 over 9. Okay. Now, if we do it this way, notice now, okay, I can simplify things. So 18 over 9 is going to give us 2, so that's going to be 2y, and then 9 over 9 is going to give us 1. So 2y plus 1. So that's one way to look at it. Another way to look at it is make sure that when you are dividing, that it's being divided to each term. So not only to the 9, but also to 18. Okay, so they all have a common factor of 9. Okay, so again, so this 9 here has to go into both of the for 18 as well as for 9. So you can't just say, oh, I have 9 here. I can eliminate that and have 18y. That's not true. Okay. Okay. So the best way to again rewrite it is rewriting it in this form so you can see clearly, hey, I have to divide it to both terms. Okay. All right. So it's the same thing for this one. Again, if I rewrite this as 15x over 5 minus 20 over 5, okay, that's going to give us 3x minus 4. Okay, so for this one, it says a sidewalk has a constant width W and several short sections with lengths 12, 6, and 5 feet, as illustrated below. Write and simplify an expression that gives the number of square feet of sidewalk. Find the area of the sidewalk if its width is 3 feet. Okay, so it's saying that the sidewalk has a constant width W. Okay, so um, so in this case, right? So this here, this is my width, right? Right? So we know that to find the area, okay, of this, or find the area of a rectangle or square or anything like that, it's base times height, okay, or length times width. So in this case, we have, if we break it up into three parts, we have this part here, right? So let's say this is A, this is B, and then this is C. So for A, right? For A, the formula, right, is going to be length times the width, correct? We know the length. The length is 12. We don't know W. So W is there. All right, so I'm doing part A right now. It's part A because I'm trying to find, I'm trying to write and simplify an expression. Okay, so then for B, okay, same thing. The length, the length here is going to be 6. I don't know why it keeps doing that. The length here is going to be 6. And then the width, right? This is our width. The width is going to be W, right? I don't know if you can see that. This is our width. Here, here, right? That's W. So that's going to be the length is 6. Again, the length here is 12. And then the width is just W. Okay. All right. And then the same thing for C. C is the length is, this is our length, is 5 feet. And then the width, all right, it's going to be here. Okay. All right. So that gives us what? 12W, 6W, and then 5W. And then we add them up, right? So that's going to give us what? 23W. Okay. So that's going to be, this here is going to represent the number of square feet of sidewalk is 23W. Okay. And then for part B, it tells us that the width is 3 feet. So again, for A, our answer is 23W. And then for B, we just plug in 3 feet for W. Okay. So that's going to give us what? 69. Okay, so that's our answer there.